How are you guys doing? It's Maldonado here. Okay, we're going to do 5.4 multiply and divide rational expressions. Okay, so now we just finished chapter 4, and I went ahead and decided to skip the first 3 sections of chapter 5, only because it may be a little bit of a task to kind of show you guys how to graph some of those complex functions, with remote learning. So if anything, when we get back to school, we'll be able to do that. We'll be able to revisit that. But I like to focus on the latter part of the chapter because the latter part is more algebraic. And it's definitely one of the more important manipulations that we, tend to work on. All right, so rational expression, okay, again, what you need to understand is rational represents a fraction. So we're going to be working with a lot of fractional expressions. Now, these fractional expressions, instead of just being, your normal 3 over 5 or 5 over 7, we're now going to have expressions. Okay, so that's now going to look like a polynomial over another polynomial. And things of that sort. All right, so really quickly, just to kind of give you guys an idea of what we're going to be doing, is like, let's say we have 15 over 25, right? I'm sure a lot of you are saying that this fraction can be simplified, right? And where is it going to be simplified to? Well, a lot of you probably say 3 over 5. Now, how we get to 3 over 5 is actually by breaking down, by factoring the numerator into 5 times 3, and by factoring the denominator into 5 times 5. Now, notice that the fraction bar here represents division. So the inverse operation to division is multiplication. Okay, so because the 5 and the 3 are multiplying in the numerator, and the 5 and the 5 are multiplying in the denominator, multiplication is the inverse operator for division, so we are allowed to cancel out the common 5 here. When 5 divides by 5, that's just going to give you 1, so we're going to get 3 over 5 as our simplified fraction. Now, we're going to be doing this with some expressions, okay? Let's give you one here on the side, just to give you an idea. Like if I had a over b over cb, okay? What do they share in common? That's multiplying both the numerator and denominator. They do share b in common. So what we're kind of allowed to do is we're kind of allowed to cancel out that b, and we're just going to get a final answer of a over c. Okay, so that's pretty much the basic concept of it, but we're going to be looking at different cases and see how they work out when we work with them. All right, so here's our first case here. It says simplify the expression if possible. Okay, so they're telling us if possible, so not all of these are going to be able to simplify. But again, what we want to look for is there any expression that's multiplying here that we can cancel out. Now, this one for us, they kind of put it in factored form nicely for us. So notice that there's an x plus 1 factor in the numerator and an x plus 1 factor in the denominator. Since those are common factors, we can divide those out. So now what we have here is we're going to have an answer of 2 over x plus 3. Okay, and that's it. So now the idea is we want all of our expressions when we start working with them to be in factored form, and then we need to identify what factors they share in common so we can go ahead and simplify them. So in this one, x plus 1 is the factor that is in common in both the numerator and denominator, so we are allowed to cancel that out. That just leaves us with 2 over x plus 3. Okay, and then that's it. All right, so let's look at the next example. Okay, here, simplify the expression if possible. So we have 40x plus 20 over 10x plus 30. Now this one, not like the one before, is not in factored form, okay? So now this is where brushing up on all those skills of factoring from earlier in the year are going to be very, very important. So we're going to be doing a ton of factoring in this chapter. So we have 40x plus 20, okay? So we need to see what that factors into. All right, so if you're talking GCF here, you're correct. The GCF between 40x and 20 is going to be 20. And then times, that's going to give me 2x plus 1. Okay, in my denominator, same idea. Look for a GCF. What do they have in common? They have a 10 in common. We're going to factor out the 10. We're going to be left with x plus 3. Okay, so here, if you kind of notice, this factor, 2x plus 1, is not the same as this factor, x plus 3. So we can't cancel those out, okay? However, if you look here, 20 over 10, what does that simplify to? That simplifies to 2 over 1. So I'm going to have 2 times 2x plus 1 over x plus 3. Okay, and there you go, there's your final answer. So the only thing we were able to do in simplifying this fraction was factor out those GCFs, and those GCFs were able to simplify for us. So notice that this eventually simplified to this fraction here. Okay, and again, as long as nothing else can simplify, then that's pretty much your final answer. Okay, next one. Here we have 4 over x times x plus 2. Okay, now here, if you notice, in the numerator, all we have is 4, and in the denominator, it's already factored for us. So we don't need to factor anything for this one. We just have to determine, is it simplified, or can we simplify anything in this particular fraction? Now the answer is that it's already simplified. Okay, now I'm going to explain this a little bit because some of you might be confused. I have a feeling that a lot of you are saying, well, what about the 4 and the 2? They share factors in common, and that is true. However, remember, I said things need to be multiplying for you to simplify them. What is this 2 doing to the x here? It's addition, right? Addition is not the inverse operator. So because the 2 is not multiplying, it's not going to be able to simplify anything for us here. Another way to think about it, right, is anytime you see an x plus a number or an x minus a number, just think of these two terms being married, okay? You cannot separate this number from the x, and you cannot separate the x from the number. If you see an addition or subtraction sign, notice that those two terms are married, so the only thing that's going to cancel that factor out is it has to be the same exact factor in the numerator and denominator. If you see a plus or minus sign, in this case the 2 is married to this x, so we can't split up the 2 with the 4, okay? So we gotta keep them together there. All right, so let's move on to the next example. Okay, here we have x plus 4 over x squared minus 16. Again, if you just listen to what I said, right, you do not want to cancel those x's, and you do not want to simplify the 4 and minus 16 because x is married to 4 and x squared is married to 16. So we cannot cancel those out, okay? So what we have to do instead is we have to see if we can factor this. So now the numerator does not factor. That's just going to stay as x plus 4. My denominator does factor, though. That's going to factor into x plus 4 times x minus 4. Now that we have our problem in factored form, is there a common factor that they share in the numerator and denominator? So here you have an x plus 4, and here you have an x plus 4. So those are going to simplify. Now, when we simplify everything from the numerator, what can we use as a placeholder in that position? We're going to use the number 1. In the denominator, we're left with the x minus 4, and there you go. There's your final simplified answer. Okay, so again, factor it first. Factor as much as you can first. Once everything's broken down into factored form, then it's just a matter of seeing what is common in both the numerator and in the denominator. All right? Okay, let's move on to the next one. Okay, so here's one that's going to involve more factoring. Again, do not get tempted by everything here that kind of looks similar, right? Notice that it's kind of like a marriage here with all the the 2 minus signs here. So we cannot separate any part of those. We cannot do that, right? So what we need to do is factor, 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 factor. That's always going to be the first thing you want to do. In the numerator here, I have x minus 3, x plus 1. In my denominator, I have x minus 3, x plus 2. All right, so looking here, what's going to cancel here? What's going to simplify? We're going to simplify the x minus 3 in the numerator and denominator. So what we're left with here is the x plus 1 over x plus 2. Okay, now this is our final answer. Like I said before, we cannot break up any marriages here, so we cannot separate the x from the 1 and the x from the 2. So therefore, this is going to be our final answer here, x plus 1 over x plus 2. Next example, okay, some higher level factoring, okay, because now some of these are not simplified easily. So let's take a look at this numerator here. Now it's only 2 terms. So because it's 2 terms, we're going to have to factor by the GCF. What's the GCF here? The GCF is going to be 2x. 2x times x plus 5, okay, over. Now this one here, we have to use the asterisk, so we're going to bring that back. Here we're going to do a times c. This is a. Here we're going to have b. Okay, so we're going to fill this in. We have 3, we have 3, we have 16 for b, 15's up here. Okay, so what are two numbers that multiply to the 15? Actually, let me erase that because that doesn't look too nice. 15. Okay, so two numbers that multiply to 15 that add up to 16. So that's going to be 15 and 1. Okay, any of these two fractions can simplify. Well, it looks like 3 over 15 can simplify to 1 over 5. So 1 over 5 is one factor, and 3 over 1 is the other factor. So the two factors we're going to have here are x plus 5 and 3x plus 1. Okay, so now the easy part. We notice that they share common factors, the x plus 5's here, so we're going to cancel those out. So we're going to have 2x over 3x plus 1. Again, we do not simplify the x's because in the bottom, the 3x is married to the 1, so we cannot separate any part of that. So there's your final answer. Again, this factoring process here is important for you guys to remember. So if you go back into your notes, I'm sure you guys have that there. We're going to do a lot of factoring in this section, so it's very important that you guys stay on top of how to do the asterisk method. Okay, let's look at the next example. All right, so now this one's a little different because they're asking us to multiply the expressions. Okay, so really quick on the side, if I told you to multiply 1/2 times, let's go with 1/3. How are you supposed to multiply these fractions? Well, you're taught to multiply across, right? So we multiply across, we get 1 over 6, okay? Now, what if I told you to multiply 1/2 times 4/5? Okay, what would you get? So there's two methods of actually doing this one. The first one is multiply straight across, just like you did before, so we get 4 over 10. But 4 over 10 simplifies to 2 over 5. The second method is 1 over 2 times 4 over 5. There was something called cross simplification, if you guys remember. This becomes a 1, this becomes a 2, and when we multiply across, we again get 2 over 5, just like the other answer. So what's going to happen is this cross simplification is actually going to be very helpful for us when we start to multiply some of the more complex ones. Okay, now the one we have here we can actually do with no problem by multiplying across. So let's go ahead and just erase this here. So we can get a chance, and if you need that, just pause the video, rewind it, and you can grab that information. Okay, so multiply the expression. So let's multiply straight across. Let's get a pencil out. All right, so multiply straight across. If I multiply the numerator, that's going to give me 18. 3 times 6 is 18. X to the 5th and x is x to the 6th. Y to the 2nd and y to the 2nd is y to the 4th. Over denominator, we're going to have 8 times 9, 72. X times x to the 3rd is x to the 4th, and y times y is y squared. Now it's just a matter of simplifying this fraction, which again you've done in the past. This is nothing new. Okay, so 18 over 72, we have to see if that simplifies and what is it simplified to. Okay, so I think they're both divisible by 18, so we're going to get 1 over 4. X to the 6th over x to the 4th is going to give me x to the 2nd in the numerator. Y to the 4th over y to the 2nd is going to give me y to the 2nd in the numerator. So if we clean this up without the 1, you're going to get x squared, y squared over 4. Okay, and then there's your final answer. So ones like this that have a lot of the powers, different variables, stuff like that, we can just multiply that straight across and simplify later. Okay, that one has no real issue in terms of factoring or anything like that because they're monomials. They don't have multiple terms. They're all just one term. Now this one, okay, this one here we're multiplying, same idea, but because they can be factored, always factor them first. Okay, so let's start the factoring process. My first fraction, the GCF in the numerator is 2x, and that's going to be 2x times x minus 5. In the denominator, you're going to have x plus 5, x minus 5, times x plus 3 over 2x squared. Okay, so now everything's broken down in factored form. We can start the process of simplifying. Okay, so let's find those common factors. Well, there's an x minus 5 here, and there's an x minus 5 here. Okay, then here, notice we have a 2 and a 2, so that's going to cancel. And then I have an x and an x squared, so one of the x's is going to cancel, so I'm just going to have one x in my denominator. So therefore, what do I have left in my numerator? I just have this x plus 3. So x plus 3 over, and in my denominator, I have an x plus 5 and an x. So that's going to be x times x plus 5. Again, we don't want to break up any marriages, so that's going to be your final answer. Okay, again, because it's x plus 3, we cannot separate x and 3, and we have x plus 5, we cannot separate the 2. The only eligible one to kind of simplify here is the x, but there is no x by itself in the numerator, so therefore we can't do anything else. Okay, so let's move on to the next example. Same idea, we're going to multiply the expression, simplify the result. All right, so again, we want to factor this as best as we can. So the first thing, if you notice in that numerator, you should probably write that in, I guess in standard form. So let's do negative 3x squared plus 3x over x squared plus 4x minus 5. Okay, and then this is going to be times the x squared plus x minus 20. Over the 3x. Now that we have it in standard form, why don't we go ahead and factor as best as we can. So in the numerator, we're going to factor out the GCF, which is 3x, but since that first term is negative, we're also going to take out that negative sign. So we're going to get x minus 1. My denominator here, I'm getting, we're going to do two numbers that multiply to negative 5 that add up to positive 4. So plus 5 minus 1. Times, and then just numerator, we're going to have x plus 5, x minus 4, and then in the denominator, we still have that 3x. Okay, so what's going to cancel out here? Okay, so now this is the fun part. We got x minus 1s here and here. We have x plus 5s here and here. And then we have a 3 and an x. Notice the negative sign still stays in the numerator. So our final answer here is going to be a negative x minus 4 over, do we have anything there in the denominator? No, everything canceled out. So it's just going to be negative x minus 4. Since the denominator is 1, we do not need to include a denominator anymore because it pretty much just became a whole number. Okay, so negative x minus 4 is your final answer. Okay, here we go. Division. Okay, division. We're dividing the expression. All right, so really quickly, if we just think about how do we divide, what's 1/4 divided by, 1/2 divided by 1/4, sorry. All right, so if we divide that, what are we supposed to do with fractions when we divide? We're going to keep the first one the same position. The operation is going to change to multiplication, and we are going to be multiplying by the reciprocal. So 1/2 of 4 over 1 is going to give me an answer of 2. All right, so since we're doing this idea, you're going to do the same thing here. It's just we have to factor these. Okay, so the core concept has always been embedded in you guys since you guys were younger. Now we're just working with some higher level polynomials. So, you know, as long as our factoring skills are up there, we should be okay. Let's get this out of the way. All right, so again, keep in mind, since it's division, we're going to flip the fraction first. So we have 4x, 5x minus 20. Change the operation to multiplication. We're going to have x squared minus 6x plus 8. And that's going to be over x squared minus 2x. Now it's just a matter of factoring everything as best as we can. So in the numerator, I still have 4x. In my denominator, I'm going to factor out a 5. I get 5x minus 4. 5 times x minus 4. Times x minus 2, x minus 4, over x times x minus 2. Okay, so now looking at it in simplified factored form, what simplifies here for us? X minus 2's go, the x minus 4's go, and then we have a lone x here and a lone x here, so we can kind of simplify those. Notice that the 4 and the x are not married because there's no symbol between them. It's just multiplication. There is no addition, there is no subtraction. So we can cancel out those x's. So in the numerator, what do we have? We're going to have 4 by itself. In my denominator, I only have 5. So this actually simplified nicely for us into a 4/5. You know, a lot of you may say, how does something with so many variables just simplify to a nice number? It just happens that way sometimes, you know. So in this case, everything simplified nicely for us. We got our final answer of 4 over 5. So this whole complex expression just simplified to 4 over 5, okay? All right, so this is the last slide of the day. It is division, but notice that one of these is not a fraction. Okay, so what can we do so that it is in fraction form? Well, you're right. All we have to do is just put it over 1. Okay, so now let's go ahead and divide. So if we divide, we know the first thing we need to do is rewrite this in terms of multiplication. So there's your numerator, there's your denominator of the first one. We're going to multiply by 1 over the 2x squared plus 5x. Okay, so we're going to need to factor this. We're going to need the asterisk for this first one here. Okay, so we have 2, 2, negative 10, positive 3. So that's going to be a 5 and a negative 2. This here is going to simplify to 1 over negative 1. So these are the two factors we're going to be using. Okay, so that's going to give me 2x plus 5, x minus 1 over 6x times 1 over, if I factor out an x, I get 2x plus 5 in that denominator. Okay, so what's common? Well, the only thing that's common so far here that I see is the 2x plus 5s. So then what is going to be our final result here? We're going to get x minus 1 over 6x times x gives me 6x squared. There you go. Here's your final answer. All right. So again, hopefully this video was informative. Again, you're going to be doing a lot of factoring, especially moving forward. You know, we're going to do multiplication and division in this section. The following section, we're going to add and subtract these fractions, and then we're going to end off with some equations. All right. So again, factoring is very important. Please, again, if you forgot, please freshen up on your asterisk. You know, you're going to be doing a lot of factoring, so get those notes out from earlier in the year. Okay, and hopefully you guys do well with this one. All right, so can't wait to go back to school, but for right now, we're going to have to keep doing things this way. Hopefully this works. Have a good day, guys.